कल पिछले दिनों हमने आप लोगों को actually I have given you the idea about the thermal velocity, and today I have to discuss about the velocity, and I have told you in the last class that this thermal velocity, average thermal velocity that was equal to 0, and I have given you this was denoted by U. Now I have told you in the last class that this thermal velocity will play a very good role to determine the drift velocity. Now I am telling you about the drift velocity. Drift velocity of air. Right? Now, see, if the conductor is connected with battery, what I have told you, that if the conductor is connected with battery, when it will be connected with the battery, in that very case, as soon as it is connected, this makes very fast phenomena where the charges are being separated because the external electric field is active here, right? Electric field. But these charges which are induced will not be accumulated. The charges will not be accumulated, as a result of which these negative charges will be attracted by the positive terminal of the supply, as well as these positive charges will be attracted by the negative terminal of the supply. Right? So, these electrons found inside the material will start to move opposite to the direction of the electric field of light, and hence no electric field will zero inside the conductor because the accumulation of charges will not be continued. Right? So, I want to say two things will act here. First condition, we can say the free electron will move opposite to the direction of electric field. Next, the separated charges at two ends of conductor are not accumulated, and hence it is attracted towards the terminals of supply. I think it became clear to you. Now this free electron will get a force, because from electrostatic we are knowing that E is equal to F by Q. The electric field E was given to you, E is equal to F by Q. So a force F will equal to Q into E will act on this free electron. And when the force will act on the free electron, it became accelerated. And during acceleration, it moves fastly and collide with neighboring free electron, atoms, kernel. I have told you in the last class. The collision will fast, and in that case it will lost its acceleration, and after that it moves with a very constant velocity, just drift, just flow, and this speed is called as drift velocity, because we are going to consider the velocity or the collisions of all free electrons residing inside the conductor, not only one. We only assume one case. Suppose to understand the collision and the drift velocity, I am just saying you a very simple way to understand that every molecules or every free electrons inside the conductor should be taken as dead except one. Now suppose one electron is here. This electron will move randomly. It will collide with the kernels and other molecules, atom moves towards here, then towards here. I have told you just randomly here. Suppose it will come at this place. So certainly, while they are moving with larger speed, the speed was thermal speed, and it was nearly equal to 10 to the power 6 meter per second. I have told you in the last class. But here, see, the collisions are being made by the free electron, but the distance traveled by this free electron is very less, and hence the drift velocity will be very less. This distance is very, very less. So this velocity will be very less, very less. So the electron will move through the conductor very slowly from one end to another end. So it is called drifting of the free electron. Now we consider several free electrons residing inside the conductor. What will there? Several free electrons will be there, several collisions will be done, and so we will find that the drift velocity Vb will equal to lambda 1, lambda 2, lambda 3, lambda 4 up to lambda m by n. A question comes in your mind, what is lambda? So, I am telling you, lambda denotes the free path. What is the free path? So, free path will be the distance traveled by the free electron two successive collision. In two successive collision, the distance traveled by the free electron is known as free path. So, I am telling you, I am writing here, distance between two successive collisions, and you are knowing that the distance is very less because the free electrons are compact as well as the molecules, atoms, ions, kernels, these all are filling inside the conductor. So the path, the free path is very, very less, and so if we consider the collision of the several free electrons there, we consider mean free path, and this is called mean free path. Mean free path. I have just written here in mean free path here. What will they? And the other term is tau. This is called relaxation time. I am giving you the idea about the velocity by which the free electrons are drifting from one end to another end. So here tau, what is tau? Tau is the relaxation time during which, the time in which two successive collisions is made between the free electron, atoms and ions. So suppose this molecule, this electron will move from here. This is lambda 1 time tau 1. From here, it moves from here. this is tau 2, lambda 2, this is lambda 3, tau 3, this is lambda 4, tau 4. These are the times. So what will they? You have just told here. Then the drift velocity will be called as lambda 1, lambda 2, lambda 3, lambda 4 up to lambda n divided by tau 1 plus tau 2 plus tau 3 up to tau n. So I have told you this will equal to average and that will equal to tau average. Clear? Now note it. So, I have taken the idea about the drift velocity just now. See, the force, we are just going to calculate it. Calculation for drift velocity. The force acting on electron. The force acting on electron. See, what will they? I have given you that E is equal to F by Q, F is equal to QE. So we can write here F is equal to E into E. F is equal to E into E. Charges E is taken negative, so you can take here negative, but so, the acceleration A is equal to F by m E by m. Charge is taken negative. If E is taken negative, then what we can write? AE is equal to EE by m. One thing comes into consideration, always gives a person deviate from the idea of the free or drifting, because I have told you acceleration is found or got by the free electrons when it is supplied the charges. So what will here? The free electron will move. The free electron will collide. The free electron will collide and the time is very short. I have told you just now. But where it will collide, it will lose its acceleration. And when its acceleration will lose, what will be? Again it will start its speed. And from where this speed will come? I have told you, it will come from thermal condition. Due to thermal condition of the conductor. I have told you the difference of temperature has been found there. So, again it will start. See, suppose here is electron. Electron will move with the thermal speed u1 and it will collide with other, getting velocity v1. Acceleration suppose a1, tau time is t1, tau 1. Now suppose here again it will get u2, velocity v2, time tau 2, again it come here, collide here, suppose it again become u3, v3, tau 3, collide like this way, now this way. So the average velocity what we find during successive collision, the acceleration of the electron is lost or lost, and hence it again moves with a thermal speed. collisions here, if we consider the successive collision of all free electrons inside conductor, what will be the velocity will be very less. The movement towards the direction of the opposite to the direction of electric field, that will be very less. So the drifting of the electron will very slow. So the drift velocity Vd will equal to, for first electron, u1 plus a tau 1, u2 plus a tau 2, u3 plus a tau 3, and so on, by n. So we can write here u1 plus u2 plus u3 up to un by n plus a tau 1 plus tau 2 plus tau 3 up to tau n by n, I have told you. So what will be? This is the average thermal velocity. This will equal to 0. Average thermal velocity is 0. Right here. Average thermal velocity is 0. So this will equal to a tau average. And a is known as minus e by m into tau. So drift velocity v is equal to minus e by m into tau. This is the drift velocity of the free electron, and if you put all the value, on putting the value of all parameters, we find drift velocity Vd is equal to 10 to the power minus 4 meter per second. So it becomes clear that being a large acceleration, getting large acceleration, several collisions are made here, and these several collisions gives the idea that when the acceleration lost, after that they are drifting in the direction opposite to the applied electric field. Clear? So now we can say Vd is equal to 10 to the power minus 4 meter per second, and this is the idea of the drifting of the speed of electron. So one thing should be clear. I have given in the first class and the second class also. When the supply will be connected with the conductor, the current will move, the charges will move in the direction, in a particular direction, very slowly. So what we can give you the definition for that, note it. The average velocity of the free electron when a conductor is connected with supply or external electric field. Supply of the free electron connected with supply is known as drift velocity it should be noted that electron is moving perpendicular to the cross-sectional area. Clear? I think everything became clear. कितना मिनट हो गया? See, I have told you Vt is equal to minus E by m into tau. But whenever we consider the case of current electricity, we will always use potential difference because charges are moving from higher potential to lower potential. So here we have to write this electric field in terms of potential, and we are knowing that V is equal to V by L, where V is potential difference, therefore Vd is equal to minus E V by M into L tau. E is equal to, in electrostatic we are knowing E is equal to minus dV by dr from there, and L is length of conductor. This become over. Now we will consider, whenever we start to summarize this idea, if what will be suppose tau, V, M, L, E, Vd, these all gives you the measurement of the drift velocity as well as what will the length of the conductor can be calculated by this formula. Clear? Now we can say, whenever we want to consider the case of current, what will the case of current, how the current will be considered, these all things be there. If temperature will move, what will the effect on tau, what will the effect on this length, what will the effect of the mass, this will be completed by us in the last, in the coming classes. So this will be continued. The lecture becomes large, so I am finishing here.
Này